All right, so it says determine if the point 3 squared is 7 is on the circle. So we're wondering if this point's on our circle that has a center at the origin. So where's my center at? Anybody?
0, 0.
Oh yeah, 0, 0. This will be way easier than the way I just tried to do it. And contains the point 0, 4. So if my center is at 0, 0 and it contains the point 0, 4, then I also know it's over here at 4, it's over here at 4, and over here at 4. So my circle goes through these ordered pairs, right? So the question is this ordered pair on that circle? Well, it would be kind of hard to look at it and see, well, am I over 3 and up 2.5? Is it on my circle? It could be, right? How could we know for sure if it was? We could write the equation and substitute it in, okay? So let's write the equation of this circle. This circle has a center at 0 and a radius of how much?
4.
4. So I'm going to go x squared. How come I didn't put plus 0 or minus 0 there? I mean, I could have, right? But does it matter if I have the 0 there?
No.
So a circle with center at the origin will just have x squared. And then I'm going to have plus y squared. And it's going to equal to how much? 4 squared, right? So my equation of my circle is x squared plus y squared equals 16. And I want to know if this point is on that circle. So what I'm going to do is substitute these values in for x and y and see if they make a true statement. So the second part over here says substitute in the ordered pair. So I'm going to substitute the ordered pair into this equation that I just found, and I'm going to see if it works. So for my x, I'm going to put in 3. For my y, I'm going to put in the square root of 7. And I want to know if that equals 16. If it does equal 16, then the point's got to be on my circle. If it doesn't equal 16, then that point is not on my circle. Is that making sense? So what's 3 squared? 9. And what's the square root of 7 squared? 7. Because do you guys remember yesterday I reminded you that a squared and a square root cancel each other? So you're left with just the number. So did 9 and 7 give me 16? Yeah, 16 equals 16 there. So is the point on the circle? Yeah, it is, because it made my equation equal itself. So third thing you do is you look and see if this is a true statement. If it is a true statement, my answer is yes. If this was a false statement, my answer is no. Okay? All right, so then it says, well, what about these points? Are they on the circle that we had above? Well, our circle we had above was x squared plus y squared equals 16. I need to check these points to see if they're on that circle. So what am I doing with these ordered pairs? I'm substituting them in for the x and the y. Okay, so I'll have a negative 4 squared plus 0 squared equals 16. And again, you guys, when you do a negative 4 squared on your calculator, make sure you put those parentheses around the negative 4 so that your calculator does negative 4 times negative 4. Otherwise, it gives you that negative sign in front, which makes it wrong. So negative 4 squared is a positive 16. So 16 plus 0 equals 16. Is that true?
Yes.
Yeah. So is this ordered pair on my circle? Yes, it is. Are you seeing how this is going to work today? You're going to find the equation of your circle. You're going to substitute the ordered pairs in to see whether or not they satisfy that equation. So again, my circle's equation was x squared plus y squared equals 16. My x value is 6. My y value is 2. So I substitute it in. 6 squared plus 2 squared. And I want to know if that's equal to 16. What do you think? No, already too big when you got 36 right there, right? So the answer there is going to be no, that point is not on my circle. Okay, one more time. Square root of 8 and square root of 8 is my ordered pair. My formula or equation of my circle is x squared plus y squared equals 16. So I'm going to do the square root of 8 squared, the square root of 8 squared, and I want to know if that's equal to 16. Anybody remember what I get when I square and square root a number? You get that number, right? So this is going to be 8 plus 8. Did that work? So is it on the circle? The answer would be yes. Okay. Questions on how I did that? So again, just to point out, because I tried to mess you guys up before we started this recording, was when it says that the circle has a center at the origin, meaning 0, 0, you'll always have that x squared and y squared starting out with nothing added or subtracted to it. And then you'll just equal it to the radius squared. So today when we're doing these kinds of problems where it says is the point on there, you're going to use that x squared plus y squared because your circle always will be at the origin. Okay, unless they give you the equation to work from. All right, next one says solve for the missing measure. And then it says that the circles are similar. Well, we already know circles are similar. We already talked about that. But AC equals 12. So from A to C is 12. It says BC, so the whole length is 36. Then it says AD's arc is 15. Find EB. So I'm looking for this right here. Okay. Does anybody have an idea of how we can do that? Is it equal to, oh, is the arc going to be the same? So this time, because it didn't say degrees here, it's talking about the arc length. So you would be right if it was in degrees, Jasmine, because that would be a central angle. And the central angles would make those arcs degree measure be the same. But because this doesn't have a degree on it, it's talking about the length of this arc. So that would not be the right length up there. But I love that you're thinking about that central angle rule, because that would work if this was a degree measure there. Okay. Oh, I love that. That's exactly right. Austin just says, can I just cross multiply? Well, how would you set up a proportion to cross multiply? You have to compare parts of the circle together, right? So could I go the radius of the little circle compared to the radius of the big circle? Would that be okay if I did that? And then I would set it equal to the arc of the little circle over the arc of the big circle. And I don't know the arc of the big circle, so I'm going to call it x in my equation. Okay, does that make sense how I did that? So because I chose to do the little circle first, I had to have my part from the little circle on top both times. Okay, because I'm comparing. So I cross multiply. I go 12 times x. And then I do 36 times 15. Anybody got that? 540, thank you.
540.
Next step, divide by 12. So x equals 45. So if this arc is 15, this arc is 45, okay? Another way you could have done it was you could have found the scale factor. Tell me, what did I multiply 12 by to get to 36? 3. So what do I have to multiply 15 by to get to 45? 3. So I would have just taken this 15 and multiplied it by 3. I like cross multiplying because it works for every kind of thing you can compare. But you see how you could have just found the scale factor? If we knew that the scale factor was 3, then we could have used the scale factor to multiply by the other part of the circle. Okay? All right, last problem. It says a circle has a radius of 7. It is dilated with a scale factor of 3. What's the new radius? Do you guys remember dilated means make bigger or smaller, right? So if the original radius is 7, and I scale factor it, anybody remember what we do with the scale factor? We multiply by it. So if my scale factor is 3, what's my new radius going to be? 21. The new radius is 21. Because I would take that 7, I would multiply it by the scale factor, and I would get 21 for my answer. Okay? Questions on that?